Hello everyone, welcome to solve this math Olympiad algebra problem, and here we have 3 to the power of n plus 9 to the power of n equals to 27 to the power of n. And now we solve this problem for the values of n. So the very first step we are going to do is, here first we rewrite this equation as 3 to the power of n plus, we write this 9 as 3 square and its whole power n equals to, we write this 27 as 3 cubed and its whole power n. And now here we use the nice exponential law, and you know about this law. If we have a to the power of m to the power of n, it is equals to a to the power of m, a to the power of n to the power of m equals to a to the power of m times of n. So here we just interchange these two exponents and it will always gives us the same answer, so that it cannot factor our final answer if we interchange these two exponents. So now here we need to interchange these two exponents on both of the sides, and we rewrite this equation as 3 to the power of n plus 3 to the power of n and its whole square. So here we move this exponent to the n, and we move n in the inside the square bracket. Then we interchange these two exponents as well, and we write it as 3 to the power of n and its whole cubed. So now you see here we have 3 to the power of n with a common expression. So now we convert this exponential equation into the cubic form, so that we just take here our y equals to 3 to the power of n. So now we substitute y equals 3 to the power of n on both of the sides of this equation, and it will be written as y plus y square equals to y cubed. So now this equation will becomes in cubic form. So here we first rearrange the terms and we move these two terms to the right hand side, and it will becomes y square, y cubed minus y square minus y equals to 0. And now you see here we have y be the common expression, so that we take it common y here, and we get y square minus y minus 1 equals to 0. So now we have two cases here. So our first case is we take y equals to 0, and the second case is we take y square minus y minus 1 equals to 0. So now here we back substitute the value of y, and our y is equals to 3 to the power of n, so that we substitute this value here, and it will becomes 3 to the power of n equals to 0. So you know that this is exponential function. So we very well know about exponential function. It cannot gives us the negative value, as well as it cannot be equals to 0. So it is not possible an exponential function equals to 0, so that we rejected this case, and we will just proceed here this case only. And in this case, in order to find the value of y, we first use the quadratic formula, so that we will now write the coefficients of this equation, and the coefficients are a equals to 1, b equals to minus 1, and c equals to minus 1. And our quadratic formula will be written as y equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So we now substitute the values of a, b and c in this quadratic formula, and it will be written as y equals to minus times of minus 1, because the value of b is minus 1. We substitute it here, and it will becomes plus minus square root of b square. So our b is minus 1 square minus 4 times of a is 1, and c is minus 1, and this whole divided by 2 times of a, and our a is 1. So this implies that we have minus times of minus becomes plus 1 plus minus square root of minus 1 square, and minus 1 square is plus 1, and this minus times of minus becomes plus 4, and this whole divided by 2. So it will be equals to 1 plus minus square root of 5 divided by 2. So these are the two values of y. So now in the next step we convert this in two cases. So our first case is we write y equals to 1 minus square root of 5 over 2, and the second case is we write 1 plus square root of 5 over 2. So now we back substitute the value of y here, and the value of y is 3 to the power of n. So we put this value on these two cases, and it will be written as 3 to the power of n equals to 1 minus square root of 5 over 2, and we have 3 to the power of n equals to 1 plus square root of 5 over 2. So first we focus on this case, and in this case we know that this expression gives us the negative value, but this is the exponential function, it is gives us the positive value. So it cannot be possible an exponential function equals to some negative value, because exponential function always gives us the positive value. So that we rejected this case as well, and we can just proceed here this case only. And now here we first copy down this statement here, and it will be written as 3 to the power of n equals to 1 plus square root of 5 over 2. So now we solve this expression and we find the value of n from here. So now in order to find the value of n, here we need to take the log on both of the sides, so that now we take log, and it will be written as log of 3 to the power of n equals to log of 1 plus square root of 5 over 2. So here we use the property of log, and we move this exponent in the front of this log, and it will become n times of log 3 equals to log of 1 plus square root of 5 over 2. So here we move this log 3 to the right hand side, and it will becomes n equals to log of 1 plus square root of 5 over 2, and this whole divided by log of 3. So here we have another property of log, in which we combine these two terms, and we write combined form of this as log base 3 1 plus square root of 5 over 2. So this is the our final answer of this question. And now if you find the exact value of n, then you need to use the calculator or log table, so you get the exact solution of this value. So if you use the calculator, then you get the exact value of this problem is 0.438. so this is the decimal form of the solution of this problem, and these are the two solutions of the given question. These are the two same solutions, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.